In problem number 1, we've got to find the derivative of this, and the first step is going to be to get the x into the numerator. And keep in mind, in this situation, it's the 4 is fine. I don't care about the 4, but I need the x of the numerator. And the way I'm going to move that is making a negative exponent. And once I get that straightened out, then I'm going to use the power rule to find the derivative. So let's go ahead and take a look at that. First, let's write the original. 3x to the 5th minus 7 all over 4x. So if I bring the x up to the numerator, the entire numerator is going to get multiplied times x to the negative 1 power. So it's going to look something like this. 3x to the 5th minus 7 all times x to the negative 1. And it's still going to be divided by 4. Now I'm going to worry about distributing this x to the negative 1. That's going to give me 3x to the 4th and then negative 7x to the negative 1. And it still will all be divided by 4. And in this situation where you've got a binomial divided by 4, well, that's each term is going to be divided by 4. So I'm going to separate these now. And this is what it looks like. And keep in mind, I have not started finding the derivative yet. But now I'm going to. I'm going to use the power rule. So I'm going to rewrite it as 3/4 x to the 4th and then minus 7/4 x to the negative 1. Now I'm going to multiply 4 times 3/4. That's going to give me 12/4 or 3. And then again it's going to be x 4 times 3/4 times x to the 3rd minus now negative 1 times negative 1 is positive 1, so it's going to be still 7/4 x to the negative 2. The 4's will cancel out. This will give me 3x to the 3rd plus 7/4 x to the negative 2. And then if I want to rewrite it so the x has got a positive exponent, I bring the x down and make it a positive x squared. Now keep in mind, like we talked about in class, I could leave this the way it was written above and just find the derivative of the numerators. So this is going to be 12x to the 3rd over 4, and this is going to be 7x to the negative 2 over 4. And then when I simplify it, it becomes 3x to the 3rd, and then this will still be 7x to the negative 2 over 4, but it'll quickly become 7/4 and then bring the x down, so x to the squared. You see how these is the same thing. So it doesn't matter which one you do. Now in number 2, I'm going to rewrite it once again. Now in this case, the entire 4x minus 5 is going to have to come up to the numerator. So that's right now to the first power. And think of that denominator as being a group. So the whole thing has to go. And then I'm going to use the chain rule because I'm going to clearly have this group up in the numerator once I have this moved. And then once I have the derivative using the chain rule, I'm going to substitute the x equals 2 into my derivative, and that will give me the slope or the gradient when x equals 2. So let's go ahead and work this out. Y equals 8 times 4x minus 5. So now I'm going to move this up, and it's going to become 8 times 4x minus 5 to the negative 1. When I use the chain rule, remember that's the derivative of the outside times the derivative of the inside. So that's going to be negative 8 times 4x minus 5 to the negative 2. And the derivative of the inside is 4. So multiplied times 4, I get negative 32x, or I'm sorry, 4x minus 5 to the negative 2. And I can go ahead and plug in my x equals 2 at this point. My calculator is completely capable of using negative exponents, so it's going to look something like this, giving me an answer of 32/9. So now I could rewrite this with a positive exponent. It's going to be negative 32 over 4x minus 5 squared. And I mean, you'll see that it's a little bit easier to do this if you're not using a calculator. If I substitute the 2, well, it becomes negative 32 over 4 times 2 minus 5. Well, 4 times 2 is 8, and then minus 5 is going to be 3. 3 squared is going to be 9. That's going to still give me negative 32 over 9. Like I said, your calculator will work it out either way. And it doesn't make a difference if you really just need to find the slope. So that's all we have for this one. Thanks for watching.